Good day, Miss. We are from Group 31. Today, we would like to present our computer network project. So, our group member include Tai Li Wei, Tin Tianxing, Lin Yiyang, and Yu Yikai. So, let us start with the project budget. The total cost of establishing or upgrading the network infrastructure is calculated by sum the expenses for network hardware and component, network software and configuration, and cabling and socket component. This comprehensive approach ensures that all critical elements are accounted for, enabling seamless connectivity and functionality. For this project, the costs are as follows: 734,015 ringgit and 3 cents for network hardware and components, 10,567 ringgit and 54 cents for network software and configuration, and 1,699 ringgit for cabling and socket component. Therefore, the total investment required amount to 746,281 ringgit and 50 cents. So the following table provide a detailed breakdown of the hardware and component required for the network setup, include the quantity and respective price. The list comprises essential devices such as router, switch, server, and endpoint, which together form a robust and efficient structure. So for this setup, the total proposed budget amount is 734,015 and 3 cents. The network configuration includes the purchase of two Microsoft OS licenses, 10,567 ringgit and 54 cents. Besides, a detailed breakdown of cabling and socket component requirements is provided, covering the cost incurred for each item to ensure transparency and effective budgeting. These components are essential to support a reliable, high-performance network setup with an estimated total cost of 1,699 ringgit. The man-hour requirement for this project will consist of 4 workers, each contribute 2 hours per day over the course of 59 working days. This allocation amount to the total of 472 work hours, and with this time distribution, the project timeline is effectively met and ensure efficiency utilization of resources and supporting the successful completion of tasks within the planned schedule. The logical topology illustrates the virtual connection among devices in the network, highlighting how data flows between them. It also includes the addressing scheme, which assigns IP addresses to each device for seamless communication. This ensures proper organization, efficient routing, and enhanced management of the network infrastructure. The physical topology demonstrates the actual physical connection between devices in the network. It outlines the placement of devices such as router, switch, server, and endpoint, as well as the cabling layout linking them. This layout ensures a clear understanding of the structure of the infrastructure, facilitating efficient installation, troubleshooting, and maintenance of the network.
Okay, so now I'm going to present about the configuration part. So this is the main router configuration. So in here we have created the two DHCP VCs pool, which names as STEPFU 5 and STEPFU 6, and then we create the OSPF version 3 process with the process ID 10, and we set the OSPF router ID to 3.3.3.3. So after that, we need to configure the interface for the Gigabit Ethernet 00, Gigabit Ethernet 01, serial 000, serial 001, and serial 010. So in here, we configure the interface by assigning the IPv6 address and also adjust the link and also assign the link local IPv6 address. So this is the code for the interface 001 and also the interface 010. So next is the configuration part for the lab loader. So in here we have created two DHCP version 6 pool, which named as the step 1 and step 2, and then we also start the OSPF version 3 process with the process ID 10, and then we set the OSPF router ID to 1.1.1.1. And after that, we need to configure the interface for the Gigabit Ethernet 00, Gigabit Ethernet 01, and serial 000, serial by assigning their IPv6 address and also the link local IPv6 address. And next is the internal router configuration. So in here we also create the two DHCP version 6 pool, and we name them as the step 3 and step 4, and then we start the OSPF version 3 process again with the process ID 10, and this time we set the OSPF router ID to 2.2.2.2. And after that, we also configure their interface for the Gigabit Ethernet 00, Gigabit Ethernet 01, Serial 0000 by assigning their IPv6 address and also their link local IPv6 address. And next is the ISP router configuration. So in here we also create the two DHCP version CPU, which named as step 7 and step 8, and then we also start the OSPF version 2 process with the process ID 10, and also we set the OSPF router ID, and this time we set it as the 4.4.4.4. Then for the interface configuration, so this time we also same with the previous, then we just need to configure the interface for Gigabit Ethernet 000000 by assigning their IPv6 address and also their link local IPv6 address. And lastly is the access limit configuration. So in the main router, we create an IPv6 access list and we name it as Wi-Fi, and then we deny any source traffic to the IP prefix, and which that's denied for the HTTP and the HTTPS. And then after that, we also allow all the ICMP, IPv6, and UDP traffic. And after that, we apply the Wi-Fi IPv6 SCL to incoming traffic on the interface Gigabit Ethernet 01. So in the internal router, is almost same with the previous, but it applies the admin tutor SCL IPv6 SCL to the incoming traffic on the interface Gigabit Ethernet 01.
So for the file server, the left side is the file server IP configuration. And for the right side, this is the file server FTP configuration that have been made by us. So for the web server, the left picture shows the web server IP configuration. And for the right picture, this is a web server HTTP configuration that made by us. For the DNS server, so the left picture shows the DNS server IP configuration. And the right side have two figures. The first is the DNS server HTTP configuration, and the second is the DNS server DNS configuration. So for the ISP server, so the figure on the slide shows the ISP server IP configuration. So for the access point, we also made the access point IP configuration.
Next is the testing of the connectivity of PC and router. First, we will use admin2 to ping the instructor to PC2. We will find the instructor PC2 IP address by going to command prompt and type ipconfig. Then this is the IP of the instructor2 PC. Then we will copy the IPv6 and go to admin2 and ping the IP that we copied. Then we will have four packets sent and 4 packets received. Next is pinging from course tutor 3 and pings to PC1. First, we will find the IP of the PC1 first. We type ipconfig in the command prompt and get the IPv6 address. Then we copy and go to the course tutor 1 and ping the IP address that we copied. Then we will receive 4 reply from PC1. Next is tutor 1 ping to laptop 0. First, we will find laptop 0 IP first by typing ipconfig in the laptop 0 IP command prompt. Then we will have the IPv6 address, and then we will copy the address and ping from course tutor 1. Go to the command prompt and type ping and paste the IP address that we copied. Then enter. Then we have 4 reply from the laptop. Next is the router pings to PC. First, we will use main router and pings to course tutor 1. First, we will go to the course tutor and type ipconfig. Then we will have the IP address for the PC. Then we will copy the IP address and go to the main router and type ping, paste the IP address. Then it will send 5 packet and it will receive as success. Next is ping from the main routers, pinging to PC31. PC31 IP address can be found in the command prompt using ipconfig. Then we copy the address and go to the main router and type ping the address. Then we will have 5 out of 5. Success rate is 100%. That is all from us. Thank you.